Today's outcome is I can calculate values of pressure, temperature, volume, and moles for a gas. So for your drill, we have a gas that occupies 11.2 liters at a pressure of 0.86 atm. What is the pressure if the volume expands to 15 liters? So go ahead and pause this video and take a few minutes to work on your drill and return here when you're ready to check your work. So this gas is occupying a volume of 11.2 liters at its initial pressure of 0.86 atm. We want to know what the pressure will be when we increase the volume to 15 liters. So based on the variables we've identified here, we're going to use Boyle's law, P1 V1 equals P2 V2. I'm going to go ahead and rearrange here. Since we're solving for P2, I just divided both sides by V2, so I get P2 is equal to P1 V1 over V2. So now I just need to plug in these values, and I get my answer here. Notice that units of liters are going to cancel. Now with correct sig figs, we're going to need 3, and that's because 11.2 and 15.0, those are both 3 sig figs, and our pressure here also has 3 sig figs. So my final answer will need 3 sig figs. So in classwork 4, we're looking at the combined gas law. So this combines Charles, Boyle's, Gay-Lussac's laws all into one expression here. Now this is only true as long as the amount of gas in moles, remember that's represented by N, as long as that is constant. So as long as the amount of gas doesn't change. So how can this combined gas law be used to derive the others, saving you from having to memorize so many equations? So any variables that are not used or are constant, we're going to exclude those. So for example, in your drill, we said nothing at all about the temperature. So if we cancel that out, we're left with Boyle's law here. So we can just exclude whatever variable we're not using in the question. For questions 2, 3, and 4, here are the correct answers, along with the answer with correct sig figs. So a couple of things that you need to know. Temperature must be in Kelvin. So if you have Celsius and you want to convert that into Kelvin, you do that by adding 273.15. And then, of course, we have our dimensional analysis conversion factors to convert between different units of pressure. So pause this video and take a few minutes to try these questions on your own, and return here when you're ready to check your work. So in question 2, we have a sample of nitrogen gas with a pressure of 6.58 kPa at 539 Kelvin. If the volume does not change, so volume is constant here, we can remove that from our expression. What will the new pressure be whenever we change the temperature to 211 Kelvin? So since volume is constant, I can take that out of my equation here. Now, the question wants my answer to be in ATM, but we were given the initial pressure in kPa. So we're going to need to do a conversion at some point to handle those different units. So I'm going to go ahead and plug all of my variables in and solve for P2. We can cross multiply here to get our answer. Now we want the answer in ATM, so I'm going to need to convert my 2.58 kilopascals into atmospheres. So I'm going to divide by 101.3 kPa to convert my final answer to atmospheres. And then we're going to need 3 sig figs here because P1, T1, and T2 all have 3 sig figs. A sample of 21 liters of gas is held at a pressure of 78 atm and a temperature of 900 Kelvin. What will the volume of the gas be if the pressure decreases to 45 atm and the temperature decreases to 750? So this is going to involve all three of my variables, pressure, volume, and temperature. So I'm going to just plug everything in here, and I can cross multiply to solve for V2. And then when I round for sig figs, I'm going to need just one sig fig because T1 here is just one sig fig. A balloon has an internal pressure of 1.05 atm and a volume of 5 liters. We have a temperature of 20 degrees Celsius. So we need to remember to convert that by adding 273.15. So when I do that, I get 293.15. We want to know what will happen to the volume when the balloon rises to an altitude where the pressure is 0.65 atm and the temperature is negative 15 degrees Celsius. So again, I need to convert that negative 15 degrees Celsius into Kelvin by adding 273 to negative 15. So I can plug in all of my variables here, and we can cross multiply to solve for V2. And I'm going to need to report V2 with 2 sig figs because my T1, V1, and P2 and T2 all have 2 sig figs. So in Journal Write 2, you're going to want to create your own combined gas law problem and then trade it with a partner and solve it. So this should be something similar to the problems that you solved in this classwork. So you can make up your own question, modeling it after the questions that we did in this classwork, trade it with a classmate, and then solve your classmate's problem in your journal. Don't forget to stick the sticky note onto your actual journal page. Classwork 5 is the ideal gas law. So the ideal gas law relates several variables that affect gases by combining them into one expression. So we got PV equals nRT. P is pressure, V is volume, N is the number of moles, and T is temperature. Now R is a constant here. So the R constants, there's hundreds of different values for them. These are the 3 that we tend to use the most. And these numbers all represent the same constant, the same value. The only difference here is the units that are used. So notice that for all of them, volume is in liters, moles is in moles, and temperature is in Kelvin. What's different are the units of pressure for R. So whenever you're solving this problem, you're going to pick whichever one of these numbers matches the units in your problem. So this is not an equation. These are just units. And all that they are there for is to ensure that things cancel out properly whenever we solve this equation. So for each of the following, identify knowns and unknowns. Algebraically rearrange the ideal gas law to solve for the unknown, and plug in and solve. So here are the answers along with their correct significant figures. So pause this video now and take a few minutes to try these questions on your own, and then return here when you're ready to check your work. So we have an unknown quantity of gas at a pressure of 1.2 atm, a volume of 31 liters, and a temperature of 87 degrees Celsius. We want to know how many moles of gas do we have. So we're going to rearrange our equation here to solve for N, which is moles of gas. Now remember that my temperature needs to be in Kelvin, so I'm just going to add 273 to get my Kelvin temperature here. So we're solving for N, which means I need to divide both sides by R times T. R times T cancels, and we're left with N equals PV over R times T. So now we need to just go ahead and plug in some values and solve here. So notice that I chose 0.0821 liter ATM per mole Kelvin as my constant here, and that's because I want to match my pressure units. So ATM will cancel ATM, liters cancels liters, Kelvin cancels Kelvin, so the only unit left is moles. So rounding to have 2 sig figs here, we get 1.3 moles. In the next problem, we have 3 moles of gas in a container with a volume of 60 liters at a temperature of 400 Kelvin. We want to know the pressure in millimeters of mercury. So to solve for pressure here, I need to divide both sides by V. So I get P is equal to nRT over V. So in order to solve, we need to plug in our variables here. Notice that since we want the pressure in millimeters of mercury, I had to choose the R value that has millimeters of mercury. So liters will cancel liters, moles cancels moles, Kelvin cancels Kelvin, and our answer ends up being this value here. Rounding this to 1 sig fig, because 360 and 400 are all 1 sig fig, we get 1,000 millimeters of mercury. If we have 4 moles of gas at a pressure of 560 kPa and a volume of 12 liters, what is the temperature in Kelvin? So since we're solving for T here, we need to divide by N times R, and we're left with T equals PV over N times R. So I'm going to go ahead and plug in my variables here. Notice that I chose the R value that matches my pressure units. kPa will cancel, liters will cancel, moles cancels. The only thing that doesn't cancel is Kelvin. So we get 202.17. Rounding this for 3 sig figs, that gives us 202 Kelvin. So today you should complete classwork 4 and classwork 5, as well as journal 2. Tonight's homework is homework 2, which is gas law calculations. And we will go over homework 1 and homework 2 next time, and both are going to be collected.